Hello, how are you? Today I'm going to start second part in which we will discuss about 12 to 15 remaining question of May June 2024 past paper. Okay, this is 21 version of paper 2 IGCSE physics. Okay, let's start our topic from 16 MCQs. Let's look on the statement. Which statement about wave is correct? You have to identify which one is will define wave accurately. Okay, the definition of wave is that wave can transfer energy from one point to another point, but matter cannot be transferred during the transfer of energy. Okay, this is the proper definition. First point is uh, wave do not transfer either energy or matter. No, it is incorrect. It means this option is saying that both energy and matter is not transferring during wave traveling. No, it is incorrect. Second option is wave transfer both energy and matter. No, energy is transferred but matter is not transferable. Okay, so this option is also incorrect. Wave transfer energy without transferring matter. uh yes, this is our correct option, proper definition. Okay, our option will be C. Okay, next question. The angle of incident of a ray of light incident on a plane mirror is gradually increased to the nearest degree. What is the maximum possible angle between the incident and reflected rays? Okay, I'm going to the whiteboard where you can check out what is the mean of that. Okay, this is our whiteboard. Question is that uh, suppose this is our plane mirror. Okay, this is it's all polished surface. I will show little bit points here, and this is the back side of the mirror, which will show that back side is polished. And okay, I think it's enough. The question is that maximum when you are falling a light on a plane mirror, this is a plane mirror and front side is almost a reflected surface, and maximum possible angle which can be formed between incident angle and reflected angle. Suppose that this light is falling in that pattern. Okay, if I draw a perpendicular on that plane surface just like that, the angle of incident with the normal will be this one. Okay, and reflected ray will be just like that. In this case, incident and reflected both angles are equal. This is the law of reflection. Okay, but he asked about maximum angle between incident and reflected ray. Which one is that? You have to I will show something for you. Just wait. I will remove this one so that you can understand what I want to say. Uh, Now I will again draw plane mirror. Okay, light is just like, suppose that light is falling here, just like that, and I will show from here, just like that. Okay, when you are changing the angle, I will draw a perpendicular also so that you can easily understand which one is the angle. When you will change, first of all I have to draw the normal angle, and I will draw it. No, yes, now it is accurate. This is incident ray. When you are increasing the angle with the perpendicular, then you can check this line is incident ray is moving in downward direction. The maximum angle will be that you can see this line is parallel to the mirror. If this line is parallel to the mirror, then reflected angle light will also travel in this way. So it means the angle formed by this type of situation will be 180 angle. Okay, so this is the main point which I want to show you. So our answer will be 180 degree. Clear? Okay, next question. Which conditions are necessary for light to be totally internally reflected? This basically this question is related to the condition. What are the conditions for total internal reflection? There are two main condition that light must be enter from denser travel from denser more dense material to the less dense material. In total internal reflection, when you will do experiment in physics lab, the rays are we use glass slab, and this is a more dense material, and other material is air, because when you are falling a light from glass, this is the more dense material and it is refracted from the glass into the less dense material, that is air. So by yes, this is the first condition, and second condition is that uh, for total internal reflection, the angle of incidence must be greater than the critical angle. Okay, if you look on the situation, first option is in glass dense material. No, we need more dense material. So it means first option is related to less dense material. Second option is also related to less dense material. Both are wrong. We need light must be incident from the more dense material to less dense material. So we have two options here. But on the other side, if you look on angle of incident, I as already I have told you, angle of incident must be greater than the critical angle. Okay, so D option is correct. I will give you a little bit hint of critical angle, that the angle the angle of incident at which the refracted angle makes 90-degree angle with the normal. Okay, this is a that incident angle will be called critical angle. So your D option will be correct. 7. Now we are going to move towards next question. The diagram shows a ray of light in passing from air into the transparent substance. Just like that, this is the air. Light is entering from air, and this is transparent substance like glass. Okay, glass is mostly we use in lab for refraction of light. And angle of incident with the normal no this dash line is show the perpendicular or normal drawn on that on the surface of that transparent substance. Okay, the angle between normal and incident ray is incident angle, and the angle between normal and ref, refracted ray is 30 degrees Celsius, 30 degree. And third, this is the refracted angle. What is the refractive index of the transparent substance? Remember, when light enter, I am going to write here one hint for you. We use Snell's law. Snell's law is used when light is entering from uh, air. Air means less dense material from air. Which one is less dense material? Less dense material. Okay, to the glass, which one is called more dense material? Okay, so the formula is, to find refractive index we use this formula: n is equal to sine of incident angle divided by sine of refracted angle. Okay, so here I will solve this MCQs in front of you. Angle of incident is 40 and sine angle of refraction is 30. Now sine of 40 is I have to solve on calculator. Sine of 40 is equal to 0.62 0.643. Okay, and sine of 30, this is equal to 0.5. Now divide both value. 0.643 divided by 0.5, I have got 1.286, which will, if we round off into two decimal place, because the answer is in two decimal place, 1.29, so it will be equal to 1.29. Okay, this is the refractive index. Basically, refractive index represents that when the light enters from air to any more dense material, its speed decrease. How much speed is decrease? It This can be found by refractive index. In this case, we have got 1.29. It means our speed of light it decreased to 1.29. In air or vacuum, the speed of light is around about 3 into 10 raised to the power 8 meter per second. That is a huge speed. Okay. Now we are moving towards 20th question. Uh, the diagram shows the ray of light in an optical fiber. Optical fiber, the thickness of optical fiber is the width or diameter of optical fiber is very narrow. Okay, it is very fine. It is made by a very fine glass material. Okay, which statement correctly explain the condition for the maximum transmission of light by the optical fiber? The question asked by this, you have to select the condition by which we can easily transmit the maximum light by this optical fiber. Remember, I have this diameter is very large. In practical, it is very narrow. Okay, so the principle on which the optical fiber is working is that total internal reflection. Okay, it means the light must be entered in the optical fiber. The angle of incident must be greater than the critical angle, but in that case the area is very low, so critical angle must be small when it is entering into the glass. This is the first point, and I have already told you in the 19th question that when light enter from air into the glass, the speed also decreases. Okay, so we have to understand which one is correct. The glass must slow the light as little as possible to make the critical angle for the fiber as large. No, the large we have to reduce the critical angle. Okay, that is why it is incorrect option. Second option, the glass must slow the light as little as possible to make the critical angle for the fiber as small as possible. Uh, I'm writing a dot. I think it will be correct. I have to check next question also. The glass must slow the light as much as possible to make the critical angle large. No, it is also incorrect. Critical angle must be small. The glass must slow the light as much as possible. Yes, this is, you have to understand these two words, little and much. It means when light is entering, the light, the speed must be little bit slow. No, we have to reduce the speed of light as much as possible, so that critical angle must be reduced to transfer the light as in short interval of time from one end to another. That's why this You have to focus on this word. I think the option is correct. I have to check the option, answer also. 20th is equal to D. Yes, 20. D option is correct. Okay. Now, next question is, which region of electromagnetic spectrum is used to detect fake banknotes? Fake banknotes, I will, this question is taken from electromagnetic spectrum, where we have multiple, where we have long range of waves like radio waves, infrared waves, microwaves, visible light, ultraviolet, and X-rays and gamma rays. Okay, I will give you one use of each one. Radio waves is used for radio transmission, radio and television transmission, and microwave is used for cell phone cell phone signal transmission, and uh, to transfer data, to transfer and receive data from the satellite, because these wave can easily move from the atmosphere of the earth, and information is not lost. Okay, satellite. Next is ultraviolet. Yes, ultraviolet we use to check the either your currency note is correct or fake. Okay, so our option is C. And X-rays is mostly used in clinics and in medical field to check the bone fracture. It is mostly recommended by a doctor, and X-rays is also used in airport to check the luggage of the passengers. Okay, or to check metal pieces in the luggage, just like gun and other things also. Okay, so your option is C. Let's now, next question is, a sound wave travel at 330 meter per second, the distance traveled by the center of compression and center of nearest rarefaction. Center of compression and rarefaction. This is very important point here. Okay, in the sound wave is 2.5 centimeter. It means, remember, in sound, the distance between two consecutive compression is called wavelength, and distance between two consecutive rarefaction is also called wavelength. Okay, but in that case, it has given the data of one compression and uh, nearest rarefaction. It means two consecutive compression and rarefaction distance is 2.5. It means this distance is the half wavelength. Okay, 2.5 centimeter. You have to multiply by 2 so that we can get the distance between two consecutive compression. This is the point, key point of that MCQs. Speed is also given, and you have to find the frequency of the wave. It is very easy question. I have to solve it. Remember, I will repeat again. The distance between two consecutive compression is called wavelength, but in that case, distance is given between compression and nearest rarefaction. It means half wavelength is given. We need complete wavelength, so you have to multiply uh, this term with 2. And one thing more, speed is given in meter per second, and uh, the distance is given centimeter, so you have to convert this centimeter also in meter. Okay, so I am wavelength, just wait. Okay, V is equal to F lambda. I will write here lambda. Okay, uh, LMDF. V is equal to F lambda. F is frequency. You have to find the frequency, and speed is 330 is equal to frequency you have to find. Wavelength, I have already told you, to multiply by 2.5 and divided the whole terms with 100, because you have to convert centimeter into meter. 330 is equal to F into 2 multiplied by 2.5 is 5, and if you divide with 100 you will get you 0.05 meter. Okay, so 330 divided by 0.05 is equal to F. So your answer will be, I will check from the calculator, 0.05, 6600. You will get 6600 hertz. Hertz is the unit of frequency. So your option is C. Okay. Next is, which waves are used in medical scanning of soft tissue? Remember, medical scanning of soft tissue of the human organ. Okay. Uh, Gamma rays is mostly used in radioactive power plants, and it is radioactive uh, to generate radiations. Just you have to write to produce radiations in radioactive reactors. In reactors, I will write in reactor. And other using other uses of gamma radiation is, I think it is mostly used for to destroy the cancer cell. Okay, to destroy the cancer cell, destroy the cancer cells of the body. And infrared radiation is used in television, remote televisions, and LCD remote. It is mostly used in that case. Okay, microwave is also used to heat up the toaster and grills, because it generate heat energy. And one other uses in it is we mostly use in our kitchen, microwave oven, to heat up the food also. Okay, and ultrasound is mostly used in medical field to check the internal parts of stomach and liver and large and small intestine. Okay, sometime during pregnancy we also use ultrasound to check the movement of your child. Okay, so our option is D. Is it okay? Okay, next is, which row describes suitable material for use in temporary magnet and permanent magnet. Uh, Temporary magnet, we mostly use soft iron. Temporary magnet, I will give little bit hint about temporary magnet. The magnet which can easily magnetize, I will write the temporary magnet is that which can easily magnetized and demagnetized. Okay, uh, demagnetized and magnetized. On the other hand, if you look on permanent magnet, it takes time to magnetize, and it also take more time as compared to temporary magnet to demagnetized. Okay, so we mostly recommend soft iron for the use of temporary magnet, and steel, it is mostly used to make permanent magnet. Okay, when I will start the lectures of all chapters, then I will I will provide you a deep concept of how about the magnet, how we can magnetize, what are the process to magnetize the material, and what are the process to demagnetize the material. Okay, so and one thing more, when I will start the P4 question answer, then I will also give you detail of all these things. So this is soft iron, this is the soft iron. No, permanent, this is incorrect. In permanent we will not use soft iron. So this is incorrect, this is also incorrect. If you look this one, steel is correct, but steel is not used for temporary magnet. Only B option is remaining. Yes, this is correct option. Soft iron is used for temporary magnet, and permanent magnet is made by the steel. So your option will be D. Okay. Next is a magnetic field is represented in a diagram by magnetic field lines at which point in the magnetic field strongest. Remember, uh, the region I'm showing you, this one, the region where the magnetic field lines are very close to each other, in this region magnetic field will be stronger as compared to the region where the magnetic field lines are far apart. If you look at that, the space between the lines are greater as compared to this one. So in this region, magnetic field will be weaker. So B's, if you look on the B, C, and D, these are all weak magnetic field region. But only A is remaining, that is close to the source. So it means A option will be your answer. Magnetic field will be stronger at A point. Okay. Next is, okay, a student determines the resistance of a resistor R. She uses a circuit including a voltmeter and an ammeter. Which circuit does she use? You can check the four options. Remember, I will give you one hint about this question. Remember, when you have to measure the resistance, we mostly use Ohm law. V is equal to I into R. I multiply by R. Okay, this is the formula. I for volt, which is used to measure the potential difference between the electrical component, and I is the current flowing through the circuit, and R is the resistance of the resistor. R is represented by this rectangle, and you have to when you have to use the voltmeter and current, you have to remember the rules. To when you want to find the uh, potential difference across any component, then voltmeter is used in parallel. I will give little bit information. Voltmeter is used, always used in parallel paths across the conductor. And to measure the current in the circuit, ammeter is used in series to measure the current. Okay, this is the rule to use the component. So you have to identify where voltmeter is connected in parallel path and ammeter is connected in series path. So first option is that battery cell, battery, voltmeter, resistance, and ampere. All components are connected in series. So this is incorrect. Okay. So first option is incorrect. On the other hand, if you look on this diagram, the voltmeter is connected across the resistor in parallel. This is correct. But ammeter is also connected in parallel. This is wrong. So this is also incorrect option. If you look at that, voltmeter is connected in series with the resistor. this is the wrong position. And ammeter is connected in parallel, this is also wrong position. So option is incorrect. And D is, if you look at that, ammeter is connected in series, and this is correct. And voltmeter is also connected in parallel across the resistor R, as I have told you that. So our option is D. Okay. Okay, let's move on the next question. Uh, Next question is, this is very important and very typical question of 2024. Uh, a diode and a resistor are connected across the variable DC supply. The terminal X is initially positive, and at a maximum value, the potential difference across XY is adjusted so that it changes as shown by the graph. Remember, I will give you a little bit information about diode and DC supply, then I will give you the detail what he has asked from you. A diode always worked on uh, forward bias connection. It means it always one thing more, diode is used to convert alternating current into direct current. Okay, mostly this process is called rectification. And one thing more, it only allows the conventional current, in never allow electronic current. Okay, the remember this is the symbol of diode, and arrow direction shows that only when positive side is connected from this side and negative side is connected in X side, then it will work only in that case. Okay, if you look on the question, he has mentioned terminal X is initially positive and at maximum value. He has right, the terminal X is at positive potential, and it means negative is Y is at negative. It means negative side is connected with the positive side of the diode, and this is the this shows the negative side, and negative side is connected with the positive terminal of supply. Okay, so in that case, it will not work. It will not work. Okay, and look on this diagram, it shows that the potential difference across xy, it means from this point to this point, in this region x is positive and y is negative. So in that case, positive is connected with the negative of the diode and negative is connected with the positive of the diode. It means it will not work when this potential is passing out, then your current will be zero. Your current will be zero. I will write here, your current is zero. Then when current is moving this side, this line shows that your value is now in negative side. It means now x has become negative and y has become positive. It means positive side is connected with the diode, positive side, and negative side of x is connected with the negative side of diode. It means now it will work on, it will be active and start working. So when this potential difference is applied, and it will start working and it will show some current. Okay, now I have give you whole concept. I have to raise this one so that you can easily identify the option. Okay, this is the four option in front of you. So our option will be this one. As I have told you that in this region, when this potential is applied, current is zero. So and this is the line, current is zero. Okay, and when this potential is applied, it shows some value of the current because diode start working. Now this shows that current starts to produce in the circuit. So your option is correct. uh, your option is D, and I have to check the answer also, either it is correct or not. The question was 27. 27, yes, D. Option is D. Now, next question is, when a conductor in a complete circuit cuts across a magnetic field, a current is induced in the conductor. Which statement about the induced current is correct? Remember, this question is related with the Lenz law. Okay. The question is that when conductor is placed, when conductor in a complete circuit cuts across the magnetic field, it means when remember when magnetic field is cut by the conductor as a result due to the change in magnetic field of line, the current is produced in the conductor, and that this induced current conductor will start to oppose the cause that produced it. This is the law of Lenz law. ठीक है. Okay, the option is the induced current is in the same direction. No, induced current will be in opposite direction. Remember, the current induced in the conductor will be opposite which produce the source. It means the source that is producing the uh, that is producing the induced current in the conductor is anti-clockwise direction current is flowing, then the induced current will be in conductor will be in the path of anti-clockwise, so it will not be in same direction. Wrong question. The induced current is in opposite direction to the motion of the conductor. No, the direction of the induced current is in the same direction as the magnetic field. No, I think A and C are almost little bit same. The direction of induced current oppose the change causing it. That this is the law of the Lenz law. Okay. So I am ending on 28. The lecture is very lengthy now. Now remaining question will be discussed in third lecture, and you have to subscribe this channel for daily updates. Okay. Goodbye.